So welcome everyone, happy holidays. We have another deep dive for you. This time it's a guest presentation from Edson Nogueira from Artifact. It's titled Stop Firefighting and Start Innovating with Dagster. Edson's gonna tell us about his adoption story of using Dagster and how the advantages that his team has gained from using it. If you don't already know Edson, he's a contributor to the DLT project. He's been contributing upstream to the project as he uses it. And he's also written extensively on Dagster on his Medium blog. He's written tutorials on setting concurrency limits, doing unit tests with Dagster, deploying Dagster to ECS. He wrote a tutorial on using declarative automation, and he's written about Dagster in DBT. So he's pretty well versed in using Dagster. So I'm excited to hear more about how he's used it at Artifact.
All right, Cousin. Thank you for that kind introduction. So yeah, the idea for today's talk is to all of our adoption story at Artifact. So to give you a bit of context about what motivates us, yeah, firefighting right now. All right. So to give a context, the context is that we have a team, an initiative at Artifact Latam called our internal data platform, which basically we have some tools that we use internally at the company. So we have this app called Artifactory where we use data from the employees and the staffing team uses it to allocate people, and then we have a lot of functionalities in it. And so we needed to have a platform that would allow us to have a great data infrastructure to serve that, and Artifact was managing it. So here's a picture of Leonardo Brandão. It's one of the managers and one of the main brains behind the Artifactory app. So basically, this is are the main duties of the internal data platform team. And to talk a little about me, for those who don't know me, apart from what Colton said, I like running. So I introduced me as a runner. I'm a good data engineer, but depending on who you ask, you might get the reverse answer. But yeah, that's a little bit about me. And also, this concept called Dagster Evangelist, I sometimes call to this guy on LinkedIn, Ricardo Amadeo. And he told me that he was known as a Dagster Evangelist in his team. And actually, I self-proclaimed now, but the idea is that, like I mentioned, I think that in data engineering, the right abstraction, we just think about assets, not tasks. And that's precisely what Dagster does, right? So that's the evangelism, because I think that's the working at the right abstraction level improves a lot of our workflows. And then I joined Artifact a few months ago, and then I met the team. Then we talked about Dagster with a seminar. The team found that it would be useful to try to use Dagster in the internal data platform to solve a lot of the issues that we will talk about in this talk. So that's the context behind the adoption story. So to give you a bit more detail on the Dagster promise, so what usually a team looks for when using Dagster, right? So typical data problems that have companies of all size faces, and we see this more often than we would like to. So they usually try to modernize or maybe build from scratch a data platform for people who are in an early stage in maturity. And the data platform team, especially on the engineering side, finds a hard time showing value because I mean, when you work on data engineering, we create make a lot of code, set up infrastructure, and then but it's hard to showcase what the platform is producing, right, to stakeholders and things like that. Which as you know, if you don't show the value of the work, it's hard to get buy-in to keep working on necessary stuff. And so basically, one of the main reasons of that it's hard to showcase value is because even basic features, like we have the data platform week event a few weeks ago, and as Nick said, even getting the basics, the data engineering is not so new as a field, but even get the basic stuff done is still not solve the problem. Right? Have a good development environment, have proper software engineering practice applied to data pipelines. It's still hard to find a good setup for that with the tools that are in the market. And most things don't have either the right tools or the maturity to do that. So but mostly because the tools that people use makes that hard, right? And the idea is that with Dagster, that makes our life easier to implement those necessary requirements. So basically, the main approach that we will talk about here are regarding governance, in the sense that we want to trust our data, so have a clear picture of everything that the platform is producing, So we understand the connections. If a given asset fails to materialize, which assets are impacted by that? So also implementing testing right from the start of development, because I mean, the faster we identify issues, so if you have an issue that can catch while developing locally, there's no reason to wait for deploy to identify the issue. And the faster you get to fix this, the more value you deliver, right? Because we iterate faster to find the appropriate setup of the pipelines. And also cost optimization in data pipelines, one of the most important aspect is to run pipelines only when necessary, right? So usually, if I want to create a table, is to consume data from other assets, maybe an external source or another table. And there's no point in trying to materialize a table if the data that it depends on has not been updated, for instance, right? You just run execute a cloud warehouse query and incur costs, and the data hasn't changed. So what's the point, right? And you see that a lot because with imperative orchestration, it's hard to do that. And also Dagster has this a nice implementation of declarative automation, as you explore as well. So basically, these are the prompts that these features of Dagster motivated the team to, why don't we try to implement here the internal data platform? And then that's the challenge that we entered into, right? So this is the proposal that we want to bring to the platform of Dagster, and now we'll talk about how we manage that, right? So ideally, at the end of this implementation, we'd have more trust, and we diagnose pipelines and fix pipelines quickly. We have data quality checks. As we discussed, Dagster has an easy way to set up these checks, which is very important, right, for companies of all sizes as well. And as a consequence, it also disclose how to implement that with data ops, I mean, testing, CI/CD, and that stuff. And also, we show, hopefully, we'll show how the debug pipeline is also with that. Right? So, going a bit more detail, what was the platform before we adopted Dagster? So, basically, here is as you see, a high-level detailed diagram of the architecture. But ideally, this is the core infrastructure that you had before, right? So it was done on Azure Synapse. For those who don't know, is like a data warehouse from Azure, right? Every cloud has one, so this is the data warehouse from Azure. And then basically you have these external systems like BigQuery, some Google Sheets, and the pipelines were defined as code, and it was orchestrated with the serverless function, right? The Azure functions. And although it makes a lot of sense when the frequency of the pipelines is not too high, right? To keep of this lambda, this cloud function, right? Because we optimize costs, but the problem is you have it's hard to implement those features that you mentioned here, right? Observability, hard to find to debug the pipelines before we see something downstream affected, and so basically what we had, for instance, this of course, you cannot know what is wrong here, but we, from internal fact, we can see that there are some data over here that is missing for this particular employee. And then we had to, without those pipeline alerts, we have to wait until a deployment of the application and see, oh, there's data missing over here, right? So how could we catch up that this issue before, so we could fix that before the deployment, right? So the longer it takes to identify the issue, so the more it affects downstream, and it requires more time to deliver value, right? So this is one of the issues when with those traditional tools that we use for pipelines. And also there is this concept of trust drift, in the sense that this is the idealization of what the diagram of the architecture would look like. So these are the assets that we'd like to produce. But as a development, after many talks, right, requirements always change. You have this new necessities that go over time. So when you develop, there are a lot of changes to the initial plan. And since these are not synchronous, right? So these diagrams are created separately from the code. So what you have in the code doesn't match what you had planned. So it's hard to understand what the platform doing. So if this is supposed to be what the platform is doing, why the code, if you we use this code, this does not correspond to that, right? Because it's not automatically inferred from the code, right? So we have to connect. We will have to connect another external tool to serve as a data catalog. This is the typical setup of most companies, right? We use an external data catalog. So as you see, we are accumulating many problems. So we are using many different tools that address specific needs, but they don't talk very well between each other. So these problems emerge, right? This is traditional setup. And after the migration, which we hopefully will start having deployed everything using right in the next year, the current situation of the data platform will be this. The change from Postgres to Erasure is just a minor issue, so it's not relevant to this discussion, so I'm not going into details of that. But mainly, what changed was the transformation was this DBT and DLT, mostly because of the integration with Dagster, because I mean, they talk in the same language, right, about data assets, which is, as we see, this abstraction makes a lot of difference in setting up those elements that you mentioned before. And it's pretty much the same pipelines, but they now there is an orchestration layer. Before it was just the observability functions. There will be an orchestration layer that supposedly will bring this observability lineage and all the capabilities that you mentioned. So this is the change in architecture and what that exactly means. So in practice, what you see now is that we have all of these assets that we previously had only the only way to see what the platform was producing is looking at an external diagram or maybe using some external tool. But now in a single plane, which one of the posts of Dagster stuff, right? We have a single plane where you can look everything that platform is producing, and you can directly identify, for instance, if you see that a specific table was impacted, so the materialization failed, we can directly see what will be affected by that, when it failed, and if you, as we show in a few moments, it's very easy to see from this screen, see exactly what happened, and then try to fix and rerun the pipeline, right? So this new setup will improve a lot on those issues. So find issues faster and iterate before waiting for deployment, right? So these data quality checks as well, we now have directly integrated. So we can validate if some columns are unique or have no values where it shouldn't have. So once again, we don't have to wait a deploy of the application to identify an issue with the data, right? Which improves a lot of the iteration, the value generation. And as implied by the previous discussion, but now giving more details to that, this data catalog, we get basically a data catalog for free, right? So we have everything that the platform is producing, and this is automatically inferred from code. So you imagine you go on that Friday meeting, and then suddenly you have a new demand, you have to change, create a new table, or drop someone before. So whatever change you make to the code, the data catalog updates automatically, right? Because this diagram is inferred from the code, so you don't have to keep guessing if what you see from the platform is still what is being produced because it's automatically inferred, right? So the now talking about more how these are in fact implemented. So just showing a few screenshots of the relevant code. So for instance, this is a typical YAML file from a DBT model. Like for those people who don't know DBT, it's basically a tool where you define a SQL query that you create a table in your house, and then you define a YAML file that documents it. So basically, it describes the table, the columns, and then defines some tests, right? And these tests that define the YAML are automatically loaded as data quality checks into Dagster. So this is one of the main advantages of this integration as well. It's one of the most impressive features of Dagster. So that setup so good that another thing that we thought about was the DLT integration doesn't have support for that natively, but we have total flexibility to do that, right? So in Dagster, we have this concept called the translator, where if you have a tool, we can create a translator that's basically an object that you pass the project with the tool use and then translate that to metadata to Dagster assets, right? So we implemented a feature that tries to mimic that the DBT integration, right? So we define metadata and possible tests as well in a YAML file. And then by this customization, we see the same approach by the description that we see from the YAML is showing the UI and everything like that. So we have plenty of room to customize that as well.
Interesting. I
And
just wanted
also,
to
like,
I wanted
sorry.
to call out back on that customized translator that's really cool. So you've added a metadata layer on top of DLT through your own YAML spec, and then you're customizing Dagster, the DLT integration, to read that YAML file and then add like a table schema as a metadata value on your DLT assets. That's really, really impressive.
All right, thanks for that.
Yeah, so then you have a single source of truth of your like data catalog in code through these YAML files, which is pretty
Yeah,
neat.
right.
Oh, cool. Yeah.
Yeah, the core idea is like that. We want apart from see what the platform is producing, we want to understand what it is, right? So it doesn't matter if you have thousands of assets, but we don't have descriptions or semantic meaning for that. So this is to make it that easier. So yeah, this is the idea. And also, like Dagster always propagates, like bringing software engineering best practices is very important to data pipeline. So the decoupling from business log to specific environments, it makes it easier to define mocks to the external systems and then test the pipeline. Once again, the whole idea, right? The faster we can identify an issue that we shouldn't wait for deploy is better for the team because we deliver very faster, right? So, and also a core feature of Dagster that I think it's way better than most of the tools that I have worked outside from it is this declarative automation setup. So, like I mentioned, the cost optimization approach that this brings, especially when you use the cloud data warehouses, is it's hard to overestimate. Right? So the interface, the APIs for the class automation seems like this in Dagster. So we can define these automation conditions. We can define a lot of predefined rules combined and use logical operators. So I don't want to go in details of that, but just this screenshot just show that I have plenty of room to customize the rules of declarative automation based on our needs. And after you define that, what you see is that as soon as an asset materializes, everything that's dependent on it will, and depending on the rules that you set up, will automatically update. So we don't need to wait to the other day or to the next cron schedule to update the data. And also, if the data doesn't update, we don't get the risk of rerun an entire large pipeline run and just to materialize some data that was already done and did not update it. Right? So we show that this is hard to explain with words, but we'll show a short demo on that. So now that we have talked about the high levels, just show a quick introduction of how we use that in practice, right? So I will just go to another tab over here. So basically, all of that setup, we can see now this is what looks like a Dagster UI, right? With the assets that it defines in code. So basically, we have everything that the platform is producing, like you mentioned before. And now imagine that we identify that this asset failed, right? So the last run from this asset failed, and then we can see directly from the catalog what are being impacted by this asset failing, right? So we can see the downstream graph of this asset. So we understand that these tables over here are impacted currently by the fact that this table failed. So ideally, what the workflow would look like. I'd like to know exactly what failed, right? So from this screen, how easy it would be to go to this, fix this, and then rerun, right? So we can go here in events. We will see that this last run materializing the asset failed. So look at that. We go directly here, and then we have the log message all integrated in the single place, right? So these are the DBT logs that would show if you run DBT locally, you'd see this in your terminal, right? So with the Dagster integration, we see everything in the Dagster UI. And then we can identify, for instance, probably here is a column level, a column name that was wrong, right? So we identify that, we'd fix it, and then with we could, for instance, a simple way to do that to be materialized this asset again. So materialize that. If you go back to the asset lineage graph, we
So you've already fixed the code. Now you're just going to rerun it?
Yeah, sure. Yeah,
Oh, okay.
I cannot show the code live, but
Yeah,
of course,
understand that.
I ideally would do that. So now we see that this is materializing, right? And then what you see here is that once it materializes, given that the rules that you define for declarative automation, basically, to say in simple terms, it says that whenever a dependency of an asset updates, we materialize that the next asset. So it's a basic simple rule. There's more details than that, but it's not relevant to this discussion. So we see this over here. So to get a bit more detail, right? So let's see
And like you
this
were
line
saying,
graph.
with declarative automation, if you had like eight like just schedules and things were running daily, you would have to wait an entire day for these downstream assets to be
Yeah,
updated, or you'd
sure.
have to go in and manually click them and rematerialize them. But because
Yeah,
you've set up declarative automation on this, once this broken asset's fixed and it's materialized, these downstream ones will then be triggered to materialize as well.
yeah, exactly. That's the idea. So, and also it materializes execute the asset checks as well. So if you want to, we can go to the run, right? If you have some questions. So materialize, after a few seconds, you should see those assets here starting materializing as well. So hopefully,
Yeah, and it'll take maybe 30 seconds because that's
yeah,
how often the tick runs.
yeah. So you can see the in the automation tab, right? You can see the sensor here. So it shouldn't get, probably the next tick will catch that, right? So it will launch a run and then so
And this can also be configured, but defaults to 30 seconds.
sure. Yeah, have plenty you can also configure which assets the sensor looks like because in some cases it's reasonable to have the schedule, right? Especially the far to the left we are, it makes sense to go to the traditional orchestration. But if you look, so just to finish the line of thought. So we see that after that just materialized, the sense automatically requests the materialization of everything that was downstream. Like you saw, there was three tables downstream of that asset, and now it automatically materialized. So basically, what the setup will look like after migrate is just we have only a single job, which is the data ingestion job. Right? Once we ensure that the ingestion assets are materialized, everything goes just by a declarative automation. So you don't have to worry if your data is fresh or not. It's fresh as soon as it makes sense to be fresh. So this is one of the in. I mean, we can implement this setup with whatever tool we choose, but from the tools that I have seen with Dagster is much easier than the other. So basically, it all goes from working at the right abstraction level make life a lot easier. This is the main point.
Yeah, and declarative automation is really flexible. So you could have it where like your most parent asset is materialized and everything
Oh,
downstream is updated, but that could be pretty expensive. So you could also add additional rules where it's like if the parent is updated and 3 hours have elapsed, or if the parent is updated and some other condition has occurred, then you'll materialize the downstream
yeah,
assets. But it does
yes,
allow you to have this kind of reactive nature in your asset materializations. And it's a different paradigm than other orchestrators, but it's super powerful.
yeah, sure. Especially when this project is still small, but imagine that the orgs grow, so the typical data platforms are every setup work fine when the project is small, but as soon as it starts scaling, a good setup makes a lot of difference. So I think this class of automation takes a lot of the hassle of identifying the right way to trigger pipelines, and that's one of the things. Yeah, that's it. I think this is one of the main points that motivated us. So I hopefully this demonstration gave you a taste of what is to work like with these tools. And yeah, this is our presentation for the Pod 14. Thanks for your attention.
Awesome. Thanks much, Edson. Yeah, if anybody has any questions, feel free to let us know. As a reminder, this was recorded and we'll be uploading it to YouTube. If you don't have any questions now, but you do have questions later, you can hop on the Slack and ask us there. I did have some questions though for you, Edson, before we get to the customer or not the customer, the audience questions. But I was curious, in your deployment, where are you deploying Dagster to? Is it the open source version?
Yes, this is open source. Also, we are using, I mean, it's flexible, so we can deploy, there's a guide set Docker to EC2 and for whatever. So the artifact will deploy basically to an EC2 instance, uses something like called Pulify, right? So this is a basic setup. Like I mentioned, in other projects, I have deployed to ECS as well. So in artifact, it will be kind of an EC2 instance.
Nice. And I was also curious, so you've only been at Artifact for 4 months now, and you've already gotten them to adopt Dagster, which is super exciting. Can you talk a little bit about that like buy-in process, how you were able to convince the team that Dagster was the right solution? And if there's any pushback on like other orchestrators, or if you considered any other orchestrators in this conversation.
Yeah, yeah. Basically, this is kudos for the team as well because I just reached. I entered the forum, then I gave a presentation of giving my background and talked about Dagster, and the team saw the petition as well. So it's nice when you reach to go to a place where people are very open minded because I mean this flow of ideas makes us all of us evolve professionally. And regarding other orchestrators, I it's mainly because of the depending on the skills of the team, right? So since there was no preference for that, it makes a lot of sense to Dagster. And also, I think that the main fit was the specific problems that you have with Dagster to be easier to fix than with other tools, right? Like I mentioned, the quality of automation, then this data quality checks, very easy to implement, right, with those integrations as well.
Nice. Cool. Well, those are my questions. Alex, if you have any, feel free to let me know. Otherwise, I see there's also a question from Phil.
Yeah.
Yeah, so Phil was asking about the DLT integration specifically, and this is kind of a hard-hitting question. I don't know if we'll have an answer for you here, but it's something that it's definitely on our minds. So the first one is, are there plans for Dagster to handle concurrency better with DLT? If I don't have the concurrency set to 1, I get some failures. This is a known limitation. And there was actually an update. I don't know if you saw the GitHub issue where we were talking about the race conditions if you have like the same pipeline name in DLT causing issues. But there was actually an update from the DLT team saying that that shouldn't be the case. So I'm thinking there might have been some updates that make it so that there aren't concurrency issues. I haven't explored it yet. I know, Edson, you actually added partition support for DLT. So if you're using partitions, then you wouldn't have those kind of concurrency limitations. I don't know if that's true. Edson, do you know off the top of your head about concurrency in
Yeah.
DLT?
No, I recall that contribution. Also, we saw this. It's kind of an upstream issue, right? So it's the DLT issues as well. So, I mean, there's not on the Dagster side to fix that. But yeah, with that partition setup was basically to use the partition to create different pipeline names. So basically that fixed for the case that I had at the time, but there are some edge cases that were working. Yeah, but I think in this case, it's hard to fix that on the Dagster side. So we have to on that upstream fix as well.
Yeah, it's a good thing to bring up though, Phil. And
Yeah.
I'd like to get it working just seamless out of the box. And we've been working with the DLT team too a little bit to get their input. So I think I'll follow up with them in the next few weeks to see if they have any ideas on how to improve it. You have some partitions. Oh, and you have a new pipeline name for each table. Okay. Maybe we can talk offline and we'll see if we can try to figure something out. But it's something that we'd like to solve for sure. Phil also had another question saying, I have lots of DLT assets and I added logging to see they are created correctly. However, I see them being created almost every minute, not just when I load the definitions. Why does it do this? It seems excessive. I've added deferred table reflect equals true. That's also something I don't know off the top of my head, but it's something I can look into. I wouldn't think that things would be running unless the asset's actually being materialized. It sounds like what's happening is it's like triggering something on the refresh of assets, which shouldn't be the case. But if you can message me in the public Slack with the details, I think I actually saw you open a GitHub issue on this too, but we'll look into it in more detail. Cool.
Actually, I had a question. Edson, at your team, do you guys use a external data catalog or and what primarily do you use in your data consumption layer?
Yeah, I mean, given that we are consultants firm, it depends a lot on the client. So I've seen many projects where an external data catalog was used. But the idea I think one of the main benefits that we looked when migrated to X was that, I mean, like you mentioned, the thing is that this tool solve a lot of problems that are important and usually hard to set up, right? We usually have to combine many different tools to have a catalog, that observability layer as well. So this was the idea is that we'll have all things encompassed there. So hopefully we can pull this off. So of next year, we'll bring more news on that.
And then for like the consumption layer, your pipelines are being used for an HR system, right? Is there or is there like a reporting layer slash BI layer on top of it?
Ah, right, yeah. Mainly that most of the episodes are used in downstream is used by the app, used in all the dashboards. So they also the local integration is something that we are looking into because we are using local that and then it will be fit nicely. But I mean, there's when we go to it's a global company, so there's a lot of talk that I have to get the credentials and everything. But this definitely the local integration is something that we see we have in our radar to use.
Cool. All right. Well, I think that's everything. Oh, sorry, we have one more question. Walter said, could you elaborate more how you handle the prod and dev split while developing new data pipelines? That's a really good question. So you
Yeah, sure.
demonstrated running it locally. Yeah, can you elaborate on how you then deploy that and how you are able to use both of them?
Right. Yeah, basically, it's more the traditional way in setting up for data pipelines is basically using different schemas is the simplest approach, right? So basically, you're running locally. But the one thing that calls me attention as well, because with Dagster, the local environment is pretty much the same production environment. This is just different because, I mean, when in the sense that we have the same dependencies, right? The same environment for every pipeline. Is this because the code allocation concept, right? If you run the pipeline when deployed, basically, even if you are containerized deployment, it should just run in the same image from the environment to run locally. So, I mean, we don't have to create make a huge change to replicate the production environment. So basically, in our things is just a schema change. But I mean, you can most of the environment variable. I think the easiest way is to define resources, right? So Dagster has that resources abstraction, which represent external system, right? So defining the configuration of your environment variables is I would say makes it very easy to change. So don't have to worry about that, right?
Nice. Yeah. And just to reiterate, yeah, our typical recommendation is using environment variables. And then locally, you could like emulate a Postgres database locally and connect to that through environment variables, or you could connect to a dev Postgres database, or just like a single Postgres database, but with different schemas using those environment variables. And same thing with ingestion of data. If you say are ingesting from Fivetran and you have multiple Fivetran instances, you could have like a dev and production one, but it typically is all done through environment variables, and you can have dev, staging, and prod like that. All right, now I think that's all the questions. Yeah, again, thanks so much, Edson, for hopping on and telling your story about adopting Dagster, and thanks to everybody for joining. The video will be uploaded to YouTube relatively soon, and I hope you guys all have a good, happy holidays.